In 1799, Napoleon's forces in Egypt uncovered a curious piece of granite near the town of Rosetta. 23 years and 2 months later, Jean-Francois Champollion announced that he had deciphered in full the ancient hieroglyphs carved into the Rosetta Stone. In February of 2001, the first draft of the human genome was published. 23 years and 2 months later, we remain far from fluent at reading and writing the language of life. Today, what I'll tell you about is our very small role in decoding and expanding the many languages of life. I'll tell you about how, aided by artificial intelligence, we're treating the hundreds of millions of protein sequences left by nature as the clues in a diabolical logic puzzle that separates molecular machines from random strings. And I'll tell you how we're going further beyond the bounds of nature and creating our own languages with which to write proteins that do everything from killing tumors to mitigating plastic pollution to scrubbing carbon dioxide from the skies. Proteins really are biology's problem solvers. Antibodies neutralize dangerous pathogens. Hemoglobin shuttles the oxygen that you breathe to your vital organs. And you couldn't see me up here without the opsins in your eyes that turn light into the richness of vision. But how does a protein know what problem to solve and how to solve it? As biochemists, we have this creed, basically, that sequence encodes structure, we say, structure encodes function. Every protein is written out with one alphabet, the same alphabet of 20 amino acid letters, but take a magnifying glass to some of these different groups one at a time, maybe to all antibodies, all globins, all opsins, and patterns jump out. Some of these patterns, they're local, they're next to each other, they're like words in a vocabulary. Others, they're dispersed, reflecting syntax and grammar. Vocabulary, syntax, grammar. 3 ingredients that really are the ingredients of language. In our case, highly specialized languages of life. And by repurposing large language models, the guts of ChatGPT, we've all heard of it now, but teaching them to speak protein instead of English, we can crack thousands of these sort of protein codes, these protein languages all at once. With them, we can build new immune activators, new anti-seizure drugs, even new versions of insulin. And on the fringes, we've found new words, new rules that nature has never before used to make proteins, allowing us to build, unlocking new languages for new design spaces, spaces with the carbon capturers, the plastic eaters, the tumor killers. That's why we learn new languages of life.